Kristian, first, we hear a lot about notions of data bias. And I was just wondering if you could, first and foremost, just explain to us what is meant by this term, data bias, and why it's an issue for the ethical application of AI or machine learning systems.
Yeah, so I think that's exactly the right place to start. And when people talk about data bias, I think different people mean different things. So, my background is in statistics. And as a statistician, when I hear data bias, the first thing I think is representativity or sampling bias or selection bias, which is simply to say, is everything in the population you're trying to sample from equally represented in the data? So, to sort of put a technical spin on that, does everything from the population you're interested in have the same probability of ending up in your data set? And there are a lot of reasons why that might not happen, right? So one example where that condition I think isn't met is if you say use a database of a police database of crimes to measure all of the crimes that occur, say, in a city. So the population of interest there would be the city, and the data would be the police database. Now, if the police are collecting data on these crimes in a way that, for example, is emphasizing enforcement in minority communities, then the crimes that occur in those locations will be more likely to appear in your data set than the crimes that occur elsewhere. So that data would be unrepresentative or would exhibit something like sampling bias. So that's one type of bias, sampling or selection bias. And that's sort of, like I said, the first place I go to as a statistician. Now, there are other types of bias as well, and these might be more what people are thinking about when they're, sort of speaking colloquially about bias in data. So another version of this might be measurement bias. So that is to say that the concept or the idea that you're trying to measure, you're systematically measuring it too high or too low with the data that you're actually collecting. And so one example of this might be if you're using teaching evaluations to measure something like teaching effectiveness. So many studies have noted that women, for example, are more likely to get negative teaching reviews, even when their students learn the material equally well, right? So in that sense, the women in that sample would be sort of systematically measured as worse than the men or other people, relative to some other sort of notion of the thing you're trying to measure. And this is especially problematic when there's this differential measurement bias. So this thing that I just measured here, if everybody's sort of measured too high or a little bit too low, depending on the application area, that might not be, that big of a deal. But when you have certain groups who are systematically measured too low relative to other groups, then you can induce real problems in the data. The third type of bias that I think we should talk about, and actually I'm going to talk about a fourth in a second, but the third one that's usually talked about is societal bias. So this is to say, is society representing some sort of bias, or is society really unfair in some way? So the data you have could really accurately measure reality, but reality is unfair. So for example, you could have a data set that measures, say, the salaries of all the people in a company. And say you have all of those salaries, so we don't have to worry about sampling bias. Everything has probability 1 of ending up in your data set. You have every single person in that company. And maybe you have an accurate measurement of what everyone's been paid, right? You have access to payroll. You have a very accurate reflection of the underlying system. But if there is some sort of unfairness in the way that salaries are awarded in that company, then their data set will reflect that sort of bias, that sort of societal bias. And one thing you'll notice in all of these cases, or at least in the first two cases, that I'm sort of talking about bias with respect to what. So I've talked about this in the sort of technical and maybe more concrete way of talking about things, like there's some real thing we want to measure. This population is the population of crimes. And say the thing we're using to measure it is a police database. So I would say that's that exhibits sampling bias with respect to the population of crimes. But if the police are actually accurately recording all of the crimes that they record, I would say that's an unbiased, doesn't reflect sampling bias with respect to the population of things that are policed, right? Or things that police know about. And so in that sense, it's biased with respect to what, right? It's if you're talking about the population of crimes, it's biased. If you're talking about the population of crimes that are enforced by police, it's not, right? When we're talking about this measurement bias, I mentioned the measurement bias with respect to what the students actually learn. So there's a sort of mismatch. We're talking about societal bias, we even still have that problem. Is it right or is it wrong if there's a gender disparity in wages? Some people might argue that the disparity that we observe is not a problem. In that sense, they might argue that it's not biased. And the last type of bias I think bears mentioning, and I think every data set from the beginning of time till the end will exhibit this sort of bias, whether you can fix those other ones, and we can talk about that in a minute, is, I don't think there's a great term for this, but feature bias. Like, what do you actually choose to record, right? When we're talking about something, say like manufacturing errors for screws in a factory, you can, maybe everyone will be in agreement that the right thing to record is the length of the screw, and if it deviates by some amount, then there's a problem. But when we're talking about data about people in particular, there a lot of decisions go into determining which data you're going to collect, how you're going to record it, how you're going to measure different things. And even if the data set you have doesn't exhibit sampling bias, doesn't exhibit measuring bias, your measurement bias, you're sampling from a world that's totally 100% fair, there's still somebody deciding what things you're going to measure, right? And so that in itself, I think, is a form of bias, because that will then determine the uses of the data downstream, the sorts of ways you evaluate that data. We often see that that in certain situations, people don't want to collect information on sensitive attributes, say race or gender, but that in itself is a decision that makes it difficult to evaluate whether your data is representative, or whether a model you build from that data is reflecting some sort of disparity or bias with respect to those variables. So all of these are different ways we could talk about bias in a data set.